Cool. We're all connected. Looks like. Um, um, oh, hang on. That's background noise here. Oh, hang on. That's background noise here. Okay, cool. We are live, as far as I can tell. Alright, right on. Cool. Let's see here. Getting some things moved around. Cool. Hey everybody. My name's Ian. I am going to continue working on coroutine support in basically in C++ for an API I'm working on. Excuse my voice. I don't know why it always does this. Hey, you can't even hear me. There. Hey guys. So anyways, Ian here. I'm going to work on some coroutine support for basically for what am I trying to say here? For my API project I'm working on. So I was looking at some examples, and it looks like I really want to go with coroutines. They're apparently a lot more efficient than using some of the old school like multi-threading concepts in C++, and they've modernized it to be, I guess, a little bit more compatible with the echo, more compatible with the base Linux OS methods and functionality, with more direct support for basically event notification system using file descriptors at the OS level. So, I haven't coded in, just a disclaimer, I haven't coded in C++ in 16 years or so. I feel like I'm pretty much brand new to it. A lot has changed, but we'll work through it slowly, so don't mind me, or don't be offended if I have to go look up definitions of keywords and some things that may seem very basic. If you're somebody with more experience in C++, I welcome any input or basically feedback on things I can do better. So let's get started. Okay, cool. So we got our code up here. I guess a quick review of this. I noticed my IDE was pointing out, I'm using C-line. I like it. I mean, it's actually pretty quick, efficient. It doesn't it's a little bit more bare bones than IntelliJ IDEA Ultimate, but I like it that way. It's actually more focused on just typing and writing code. It feels like, anyways. Okay, let's do a quick look here at our current class. So this is our namespace Coro. I guess that stands for coroutine. We have an event loop class for which the header file is declared here. We allow to, basically you can create a singleton version of this class, passing in the max events. That'll limit, I guess that will limit how many max events you're allowed to have. So it's going to set the internal private variable max events. Then there's the, let's see, what is this doing? Let me go to this definition. Oh, it's just an int. Oh, that's right. I'm kind of learning as I go along here. So it looks like what we're doing, let me do a quick look up on this particular epoll. I looked this up the other day, and I kind of forgot what this flag is. Okay, it looks like it just spit out a bunch of stuff here. I didn't expect that whole breakdown of the whole constructor, but let's see if we can figure out what the flag's for here. Security best practice. It ensures that if the process forks and executes a new program, this file descriptor is automatically closed in the child process. Okay, so we're creating a, let's see what this method does. Quick refresher. I think this is a system method, by the way. I think this is a Linux OS method. Same as ePull create, but with the flags parameter. Okay, the unused size parameter has been dropped. Okay. See if I can find this really quick so I don't waste too much of your time. Where is it in here? Oh, right here. Creates a new ePull instance. Security best practice to ensure that the... Okay. So in essence, it's creating an ePull instance, and ultimately it's just an integer. It's a file descriptor, a number that points to a file descriptor. Just basically an identifier for file descriptor. Max events, these are all private variables that get set on the class here, the event loop class. Stopped is defaulted to false. So events buffer. Okay, so that's where we use our max events value. And that is going to be a vector, basically an array of these ePull event types. If our current file descriptor is less than 0, that means there was an error. The method call failed, didn't result in a valid file descriptor. Okay, yeah, so this is kind of to protect from creating another event loop on the same thread. We only want one event loop per thread. Okay. Excuse me, I just ate. Alright, so current loop, this. Okay, so I guess basically if we just, I guess there's a different constructor where you don't pass max events and it's just going to default. I assume it looks like it's going to close an existing one if there's one. Oh no, I'm sorry. This is the cleanup for the event loop. So when it gets deconstructed, it'll do some cleanup. Okay, so hopefully that covers everything. We're not going to have any memory leaks. I assume once you clean up this class, all these private variables will be scoped and go away with it. They'll be released. Current. Okay, so this gets you the current existing loop or a pointer to that loop. Start it. It's going to check to see if it has pending work. If it does, then it will go ahead and run. And this loop will run until there's no more pending work. Run once actually looks at all the queues. It does some other stuff like calculating timeouts, and then basically determines a timeout for if there is one, I believe, for the current queue item. Oh, I'm sorry, I missed this. These are kind of important. Process ready queue, process timers. I'm not sure how it calculates this. Okay, so if it's a ready queue, so if we've got items in ready queue, we just timeouts automatically 0 because they're ready to go. They should be executed immediately. And then it does some calculation if there is a timer. If there are timer, it'll pull get top. Timer is a kind of this priority queue, which I'm not super familiar with, but basically it's going to order by, I think the closest timer is going to be on the top, the one that's closest to expiring. So it'll get that next timer. Looks like we got a little warning here. Okay, so this variable can be made const. So we'll do const auto. So basically if next timer is less than now, that means that it looks like it does need to, let me think for a second here. Okay, if it's less than now, then I guess we just, the deadline. So if the deadline is behind us, that means we just go ahead and run it now. That's why it returns 0. Anyways, so this is kind of in essence what that method's doing. I apologize for diving into that so deeply. But basically, if it's 0, then there's just no wait time. Otherwise, if it should wait, then it's going to pass that data for the event, max events, and then it's just going to get this in, which I might rename this in variable because I don't know what in represents. Let me see what it returns here. Okay, it returns the number of triggered events returned in the events buffer, or -1 if in case of an error. Okay, so if it's less than 1, we had an error. Otherwise, this is how many events we have. We need to go ahead and just get the data, the file descriptor from the data on the buffer, the current item, the current event, get the file descriptor, and then find our own special I forget what we named what type this is. It's like a FD registration. So we get our FD registration, I believe, from the map, unordered map. Get that registration, find the check to make sure we're not, we found it. So make sure we're not at the end. Let me try this. I want to see what this does. If init. This is kind of interesting syntax here. So it looks like get the file descriptor, and then I guess if that's I actually don't really follow this syntax. Let me just check on this. Apologize. Kind of educating as I go along here, so please feel free to chime in if you know what you're looking at. Otherwise, I'm just gonna, it'll be kind of a peer education here. Okay, so this was introduced in C++. It's the init statement. So the if statement is divided into 2 parts by the semicolon. Searches for a file descriptor. Yep, in the map. It stores the resulting iterator in a variable named it. True. So, and then it checks if it was successful, if it found it. If the key FD exists in the map, the iterator will not be equal to the end. This way, the variable it is only visible inside of the if block and its associated else block. This prevents variable pollution. You don't have to worry about it accidentally being used later in the function. Okay, so it's kind of a scoping thing. So it's basically scoping IT to this if block. That's interesting. Okay, so anyways, long story short, it looks at it, and then if it finds a registration or a what is this IT though? This is going to be, oh, it's going to be the current, oh sorry, the iterator, the map iterator, and then it's going to get the value. So that's what the second is. That will be the value. Then assign triggered. Okay. So get the events, which are casted to event type. Triggered events, okay. Which event type, you got all these sort of basically the ePoll like statuses. So assign those so we know what the we know what the triggered events are for this current ePoll instance. And then we're going to add its handle to the ready queue, whatever that is. Okay, so that's a coroutine handle. Interesting. And then if it exists, otherwise if there's a callback, it'll basically call the callback. Okay. Fair enough. Otherwise, it'll be handled via the Linux. I think the Linux's OS. When it processes the queue, I believe it'll pick up that handle later in a cycle, and it should be popping or getting top off of this ready queue, and then it should be getting. Let's see, I think there's a pop somewhere. Yeah, process ready queue, get the front, so it gets a handle. And then it'll basically say, is there a handle? Is it not done? Make sure it's not done, then resume that handle. So I assume that the handle itself is actually this coroutine handle, which has some special significance for the C++ language, where it will trigger the coroutine magic, I guess, for lack of a better understanding. And then if we stop it, that'll just change the stop flag, and that's really not a big deal. I guess that somewhere in here in our logic, we'll look at that flag in the loop, probably, or somewhere along those lines, and stop. I'm not sure why this redundant elaborated type specifier. I guess we don't need to specify that it's a struct. Register file descriptor. What I want to do is I want to see usages on this, get an idea of how it's being used. Okay, so this is our, oh, it's just the header. Okay, where is it actually used is what I want to know. I do not see this method being used anywhere. I'm going to leave it for now. It might be used for something else later. So I'll just leave that. Another different signature, same method. It's an overload. Okay, so we've overloaded that method. Let's go ahead and move on. Register, modify. Oh, okay. Now I remember. Yeah. So these are ways to call the underlying Linux operating system's ePoll method, ePoll-ctl, and then we can basically modify the underlying, basically the underlying, like, that's right, the events. We can update the data on the ePoll event at the operating system level in the Linux operating system. This probably can be a constant. Oh no, make this inline. Okay. Alright, so this will try to locate the file descriptor from the map, assign it the events. Okay, so that's just keeping our own version of basically file descriptor like registrations, just keeping them in sync. So if we update the operating system, we want to also update our own in-memory version of it to keep it the same. Unregister, self-descriptive, get triggered events. That is interesting. So we'll try to locate by file descriptor again. It's just an integer. And then if we find it, we will go ahead and just get those triggered events. Schedule. Let's see here. Okay, so we're just adding a coroutine handle to the queue. Schedule after, I guess that allows us to assign a deadline to it, so that goes into the timers queue with a deadline. Cool. Has, let's see here, pending work. Okay, it's gonna check if there's anything on the queues. Process ready queue. That'll just iterate for the current ready queue size, and then go through, get those handles. Pop. So remove it from the queue. Then if it's not done, go ahead and just call resume on the coroutine handle. All right, and then process timers. Get the current time. Go ahead and just iterate over that. Or not iterate, I mean, we're going to loop while it's not empty and while the deadline is less than or equal to now. So for all the ones that are, okay, so that's just all the ones that are up for or due, all the timer queued items that are due, go ahead and run those coroutines. Calculate timeout. Okay, I already looked at that. Okay, cool. All right, so we did our review. So I'm just going to go into working on building the basically a task template. So let's go ahead and start that. Let's just go ahead and create the file and get started on that. And I think I'm going to put that in Coro or Coroutine. Let's create a new, what are we doing here? We're doing the header class. Okay, let's do the header. Okay, we're going to do a header file for this. We'll call it task. Do I want to add it to targets? That's the question. I do want it to build, so I'm not an expert on CMake lists, like formatting, because I think there's a way you can actually specify just the just like the entire folder, so you don't have to add every single file to it. For now, I'm just gonna let the IDE do its thing. It's probably relatively smart.